Hello everyone, welcome in the module Projection of Lines. In this video, I am going to show you how to draw the projection of line when the line is inclined to both horizontal plane and vertical plane.
The problem definition is line CD measuring 80 mm is inclined at an angle of 30 degree to the horizontal plane and 45 degree to vertical plane. The point C is 20 mm above HP and 30 mm in front of vertical plane. Draw the projections of the straight line. Now at first we will note down the given data from the example. So a line CD measuring 80 mm is inclined at an angle of 30 degree to the horizontal plane. So here 80 mm is the true length of line, which is denoted by TL. So TL is given 80 mm. Then this line is inclined at an angle of 30 degree to the horizontal plane. The angle made by line with the horizontal plane is denoted by theta, which is equal to 30 degree. And 45 degree to vertical plane. So angle made by line with the vertical plane is denoted by angle phi, which is equals to 45 degree. The point C is 20 mm above HP and 30 mm in front of VP. So the position of point C is given. So position of point C is equals to 20 mm above HP and 30 mm in front of VP. So these two things are given related to point C, and total 5 parameters are given by using which we have to draw the projection of straight line. Now the point C is 20 mm above HP and 30 mm in front of VP. So the distance of point C from the horizontal plane is always visible on the vertical plane. So this 20 mm distance you have to draw above XY line, and that's why I am showing vertical arrow. Similarly, the distance of point C from the vertical plane is always visible in the horizontal plane, it means in the top view. So, while taking this 30 mm dimension for point C, we have to plot this point C below XY line at distance 30 mm, that's why downward arrow is shown. So, let's start drawing the projection of line. So at first we will draw the XY line. We will show the arrows and we will give the nomenclature as a XY. After drawing XY line, first we will locate the point C, and for locating the point C you have to mark a point on XY line. Through that point, draw a projection line which is perpendicular to the XY line, and on this line locate point C. The location of point C is given 20 mm above HP. It means we have to draw above XY line. So above XY line at 20 mm mark a point. The location of point C 30 mm in front of vertical plane means below XY line you have to plot the point C. So below XY line 30 mm mark a point. Now as in the problem theta and phi both angles are given, so this problem is related to the line inclined to both the plane. So in the front view as well as in the top view, the reduced length of line making certain angle is visible. So in the front view, a reduced length of line and the angle made by that particular line will be visible. Similarly, in the top view, reduced length of the line and certain angle is visible. Now, after marking that both points, give the nomenclature. So, for giving the nomenclature, above XY line, vertical plane is present, and on the vertical plane, we prefer to draw the front view. Below XY line, horizontal plane is present, and on the horizontal plane we prefer to draw the top view. So in the front view, we generally use the nomenclature in the dash format, and in the top view we use the nomenclature without dash format. So give the nomenclature as C dash in the front view and small c in the top view. After that, we have to locate the locus of C dash and C point. And for locating the locus, draw a line parallel to the XY line which passes through C dash. Similarly, draw a line parallel to XY line which passes through C. Give the nomenclature to that projection lines as a locus of point C dash and locus of point C. So this line is a locus of C dash. This line is locus of C. So true length of line is known, and this line is making 30-degree angle with the horizontal plane and 45-degree angle with the vertical plane. The angle made with the horizontal plane is visible in the front view. The angle made with the vertical plane is visible in the top view. At first, we will draw the true length making angle 30 degree with the horizontal plane. So, draw a line which passes through point C dash and making angle 30 degree. This line we have to mark the true length. For marking the true length, from point C dash mark a point at 80 mm on the 30-degree inclined line. To this point, give the nomenclature as D1 dash. Why we are giving nomenclature as a D1 dash? Because the line is making angle with both vertical plane as well as horizontal plane. So true length of the line is not visible in any of the view, that is front view as well as top view. So this CD1 line is not our front view. So that's why I have given the nomenclature as C-D1 dash. This C-D1 dash is true length of the line which is making angle theta with the horizontal line. Now we will mark the locus of point D. For that, draw a line parallel to XY line should pass through this D1 dash. Give the nomenclature as a locus of point D dash. After marking locus of D dash, now we will plot the true length of the line in the top view, which is making 45-degree angle with the vertical plane. For that, draw a line which passes through point C and making angle 45 degree with the XY line. After drawing this line which is making 45 degree with the XY line, mark the true length of the line which starts from point C. Give the nomenclature to that point. as D2. CD2 is the true length of the line making angle phi with the horizontal line, or we can say XY line. After marking true length in the top view, now we will plot the actual front view, then we will plot the actual top view. Now for plotting the front view of the line, draw a projection line which starts from D2, and that projection line should be perpendicular to the XY line. You have to draw this line till it meets with the locus of C dash. You will get one intersection point when this projection line meets with the locus of C dash. Give the nomenclature to that point as a D2 dash. Now why we are giving nomenclature D2 dash? Because we have transferred this D2 point by using projection line in the front view. This C dash to D2 dash distance is called as the elevation length. After getting this elevation length, now we have to plot the front view of the line. For that, take the distance C dash to D2 dash in your compass. This distance, keep your compass at C dash, and you have to rotate this D2 dash point till it meets with the locus of D dash, like this. Then give the nomenclature to the intersection point of the R and locus of D dash as D dash. Join this C dash to D dash to get the exact front view of the line. This C dash to D dash is called as a elevation length of the line. So this C dash to D dash is the elevation length, which is also called as a front view, and the angle made by this elevation length with the XY line or horizontal line is called as alpha angle. Now we will draw the top view of the line. For drawing the top view, at first we will locate the locus of point D by using the same procedure that we use for plotting the locus of D dash. Means, draw a line parallel to this XY line, and this line should pass through this D2 point. Give the nomenclature to that line as a locus of point D. Now for drawing the top view, draw a projection line which starts from D1 dash point, and it should be perpendicular to the XY line. We have to draw this projection line till it meets with the locus of point C. Here the intersection of the projection line and locus of point C, you will get a point. That point is point D1. The distance of point C to D1 is called as a plan length. Now for getting the top view of the line, we have to rotate the plan length till it meets with the locus of point D. For that, take the distance C to D1 in your compass. Keep your compass at point C and rotate this point D1 till it meets with the locus of point D. The intersection of the R and locus of point D in the top view you will get a point, that is point D. Join the line C to D to get the top view of the line. This C to D is plan length of the line as we have rotated the plan length. So this CD is a plan length, which is also called as a top view of the line. The angle made by the plan length with the horizontal line is called as angle beta. Now we will note down the answers. Now here, this elevation length we can measure, alpha angle we can measure, this plan length also we can measure, beta angle also we can measure. For getting the EPD, that is end projector distance, draw a projection line which passes through D dash D. This projection line should be perpendicular to the XY line. It means D dash and D point should lie in one line. The distance between these two end projectors is called as EPD. If you measure the distance between these two end projectors, you will get end projector distance. These are the answers which we have to find out from this projection of straight line. This completes our problem.